Okay, since sensory detection is not the same thing as perception, there's a whole area of psychological research that has gone on for a long time. The effort to sort of link sensory detection of a stimulus, what the actual energy is out here, to your perceptual experience of it. And this field, this area of investigation is known as which is the perceptual psychological experiences, right? Physics, which is the actual, physical energy that can be detected out here in the environment. The relationship between those two is not direct. Actually, I think I mentioned earlier how, you have limited sensory detection equipment, so you miss an awful lot, basically, of what's out here in our environment. You also, all of us, tend to exaggerate certain aspects of sensory inputs and diminish others. For example, we talk later about somatosensation, which is sensations from the body, right? Well, it turns out that, there's a lot more receptors that are arrayed in this hairless skin, on the palm of your hands, called the glabrous, skin. That's hairless skin here. Many, many more fine touch, kinds of detection than you have, for example, up here on, the back of your shoulder. So the mapping in the brain of your body is going to exaggerate the hands dramatically. It also exaggerates the face. It exaggerates the tongue and the larynx and the pharynx, and it diminishes the body, and the legs. It's a very funny little figure that we'll see later called the homunculus, that is really more of a reflection of how you perceive the body, as opposed to the actual, physical extent of the body. So Gustav Fechner did a lot of research trying to link the physical stimuli in the environment to your perceptual experience, and he was very interested, for example, in the auditory realm, and he was interested in, like, as you increase the intensity of a sound wave, and we'll talk about sound later, but something vibrates in the environment, and it perturbs the pressure of the medium of the environment, which in our case is air, right? So basically, it'll cause a pressure compression, and then followed by a rarefaction, or a reduction in pressure. So you can sort of map these pressure changes and get what we call a sound wave. And the higher the amplitude of that wave, the higher the difference between the most intense compression, right, and the most intense rarefaction. Well, that's increasing intensity of the sound wave, and we have a perceptual experience in relationship to sounds of different intensities. We experience them as sounds of different loudness, right? Loudnesses. So that's our perceptual experience, is the loudness of the sound, but it's related to the physical aspects of the sound wave. How great an amplitude, how big a difference is the highest compression versus the highest rarefaction. And that's related to, for example, something goes lightly, right? That's going to generate small compressions, rarefactions, so a pretty low amplitude sound wave, versus something louder will, perturb the pressure changes much more dramatically, have higher intensity, and you'll perceive a louder sound. But it's not a one-to-one relationship. He actually realized that as the physical stimulus increased in intensity, our perceptual experience of the loudness only increased a bit. So the physical stimulus actually has to increase quite a bit in terms of intensity of the pressure wave before we detect an increase in the loudness of the sound. So this became known as Fechner's law. Like, basically, the actual physical stimulus has to increase quite a bit more before we perceive a perceptual change. This area of psychophysics, one area that's really fascinating, is to think about how, our awareness, our perception of something, actually depends a great deal upon our, mental state, right? So, for example, like, it's not only the bottom up input via these sensory detection events, the ears or the hands, whatever, the eyes, but also your expectations, right? And your anticipation and your attention how alert or awake you are. All these things will, influence whether you perceive something or misperceive something. And what's interesting is there's this whole field of sort of what's called signal detection theory, where and the example that's illustrated here is that let's say you've got your cell phone, right? And you're waiting for a call, and this is an extraordinarily important call. So you're really, really attuned and attentive and monitoring, like vibration, basically from the phone. Well, you're actually setting what they describe in signal detection theory as the criterion, basically, way low, so that even small, kinds of, sensory detection events or activities, like activity along some of these networks, might provoke, a perceptual experience of a phone buzz. Actually, I find it fascinating how if you forget your phone one day, you're going to have lots of phantom phone experiences. You're going to feel that buzzing, more and more and more in the absence of the actual phone. It's actually a reflection of how much these phones have become a part of our sensory and perceptual repertoire. They're part of our bodies. And when they're removed, you have phantom phone experiences, the same way as if you lost an arm, without the actual arm sending information, the perceptual mapping of that arm will generate, powerful perceptual experiences of an actual arm. The same is true with your phantom phone. But if you set the criteria, really low, like anything will hop above, you're going to get more what they call hits. You're going to actually, you won't miss as many calls, right? Fewer misses. However, you're going to have a lot more of what they refer to as false alarms, right? You're going to think it's there when it's not actually really there. And if you don't care about your phone, if you're not paying attention to your phone, it's something much more interesting that you're listening to, in the real world. Well, the criteria is set, at the other end of the spectrum here. You'll miss more calls. You'll be less likely to catch a call, but you'll make more correct rejections, actually. And this is because, our nervous systems are trying to pull out what they refer to as the signal, the phone call, from the noise, all this other input, that's coming in and activity along these networks in the brain. And we have top-down, kind of systems that can help bias, our detection of signal versus noise in various directions.